You're sitting in room 337. It is hot in this room, as it's always hot in this room. And you're about to learn the chain rule. Well, I get to be out in this beautiful weather coaching tennis. Jealous? Let's learn. Here we go, guys. So, chain rule. Calc 1, it's a big deal. It's a huge tool to help you take a lot of derivatives in Calculus 1. Well, it's just as big of a tool for Calc 3. I want to first remind you of Calc 1, where if I had dy dx, I could say it's dy du times du dx. You notice you would multiply that out, those du's cancel, and you do get dy over dx. So if I had an example, I could say y equals, let's go with x squared plus x to the fourth. Now you guys are really good at taking derivatives, and you could just say it's y prime is 4 x squared plus x to the third times the derivative of the inside. Okay? The whole idea of the chain rule is we're going to try and start looking at this as a chain. Y is all about a u, which is all about an x. So in this simple chain, I'm kind of saying y is something to the fourth. And if y is something to the fourth, then u by itself is just this x squared plus x. And x by himself is just 1. Or sorry, is just x. So what's kind of going on here is this whole part here is dy du is the whole idea of 4 something to the third. 4 something to the third. And then the whole idea here of du dx is that's the 2x plus 1. And if you kind of want to consider that x is a little chain, you can kind of say to yourself that dx is just 1. So I could have put a 1 there, but you don't need to because it's already down to its most simple idea. Now I can upgrade it if I wanted to, and I could make it even bigger. I could say, for an example on 1, I could do the chain rule, and I could say dy dx is the same idea as dy du, let's say times du dh times dh dx. And again, if you look at that and you start multiplying, those du's cancel and those dh's cancel. Well, an example of that could be, I can make it a bigger guy and say y equals something to the fourth, and inside that something I'm going to say sine of x squared plus x. So if I want to come over here and I want to look at the chain, I could say I have a y, which is connected to, what did I go with next? A u, which is connected to an h, which is connected to a x. And the whole idea here is this y thing is something to the fourth. Sorry about that movement. The next guy would be the sine part. Next guy would be the x squared plus x part. And finally, the last part is the x. So I got to go through each part of these chains by taking the derivative. Well, the derivative of something to the fourth would just be 4 something to the third, and I keep that something the same. That, in a sense, was the dy du. Then I can multiply by the derivative of sine. Well, the derivative of sine is cosine, and I keep everything the same. That's kind of that du dh. And finally, I have to do the derivative of x squared plus x, which is the 2x plus 1, which again is that dh dx. If I wanted to, you could try and say I would have to do one more of these guys, which is that part, but the derivative of x is just 1, so you can just stop. And you can say this is the derivative of y equals sine x squared plus x to the fourth. Basically, we had to go through the blue, the red, and the green to get through that chain rule. That's the idea in Calc 1. So let's take a look at it in Calc 3. So the whole idea in Calc 3 is I'm going to have a function, w, which is f of x comma y. And from that, I'm going to say w, I'm going to build the chain for you first, and then we can look at it. W varies based off x and based off y. And I might let x vary based off another parameter. Let's call it t for right now. And I can call this guy y also varies based off t. Now for each one of these in this chain rule, I need you to make sure you understand this. This is the partial of w with respect to y. This is the partial of w with respect to x. Now it's a partial because it's part of it is belonging to x and part of it's belonging to y. Now if you look at y, everything about y depends on t. So I can say this is dy dt. That's a full derivative. And everything of x depends on t. So this would be dx dt. So if you only have one link of the chain going down, it is the full derivative. These are fulls. But if you had to split a derivative like you did here at the w getting split in x and y's, those become partials. So this guy here, I'm telling you, w has some relationship about x and y, and then I'll let you know x varies by t and y varies by t. So if I want to create the whole derivative dw dt, I can say this, dw dt. So I'm asking for the full derivative of w, all about the t's. What you need to do is you need to come down through each chain. So on one part of the chain, I'm going to have dw, oops, that should be a dx, times the full derivative dx dt. That's sending it down that part of the chain. Plus, I'm going to now send it down this part of the chain, which is the partial of w with respect to the partial of y times the full derivative of y with respect to time. So the whole idea of this is the derivative of w in terms of t. The entire chain depends on a partial about x, that's that part, which then depends on a partial about t, which is that part. Then it depends on a partial of y along with a full derivative of y. Okay? So this is the full equation for dw dt. So let's take a look at an example of that on the following page. So I've let w equal 5x plus xy plus y squared, where x depends on t and y depends on t. Every time I do this, I would highly recommend you showing the chain. It will help you. So I know I have the w. He's all about x, but he's also all about y. And x is only about time, and y is only about time. So when I ask for dwdt, I'm going to say dwdt is, I'm going to go down this guy first. That's a partial of w over a partial of x times, I'm going to fall down right here. Now this is a complete derivative because x only depends on t. So that's dx dt as there, plus, now I need to go down the next part of the derivative, which is this partial. Again, it's a partial because I'm splitting it between x's and y's. So that would be the partial of w over the partial of y times, I need one more color, let's go black, times the full derivative of y with respect to time. So if you didn't like that last slide, I think this one might have helped you with the color coordination. So now let's continue this. I'm going to open up a new video so you can check it out. This will be video number 2, and we will complete this one.